Geometric transformations. Before we can talk about any transformations, we have to understand what congruent figures are. Congruent figures are figures having exactly the same size and shape. So any two figures or shapes that are exactly the same size and shape we would always call congruent. Now that we know that, we can understand that a shape can go through three types of transformations: translation, reflection, and rotation, but will still be congruent to the original shape. So in each of these types of transformations, the shape, the B, hasn't changed size or hasn't changed shape. So we're going to learn in the next 3 slides what translation means, reflection means, and rotation means. First, translation is when the image is formed by moving every point on a figure the same distance in the same direction. And another word for this, a simple word for it, is a slide. So you can see here I have this quadrilateral, and I have moved every point on the quadrilateral to the up and to the right in a diagonal direction. So I'm going 1, 2, 3, 4 steps up and to the right. So this point moved 4 up, this point moved 1, 2, 3, 4 up and to the right, and these points would be the same. They'd be a distance of 4 diagonal moves from here to here. You can see that slides can happen. So this was a slide that happened in a diagonal direction, and you can also talk about it moving horizontally and then vertically. Here is a horizontal slide, and here is a vertical slide, or a translation. So a horizontal translation, a vertical translation. In all of these cases, the size and shape of the figure hasn't changed, so the shapes are still congruent. The next transformation is a reflection. In the reflection, the image is flipped over a line called the line of reflection. All corresponding points on both images are equidistant, or the same amount away, from the line of reflection. And a simpler word for a reflection is just a flip. So we can see here that I have this L, and I have a smaller model here. And here is the line of reflection, this black dotted line, and it has been flipped over top of that line. So this reflection, just like in a mirror, reflects over here. And this explanation here, all corresponding points in both images are equidistant from the line of reflection. Let's see that in this example. So this green dot, the top corner, is 1, 2, 3 steps away from the line of reflection. Well, when it lands over here, it's going to be the same amount away from the line of reflection. So we see that it's 1, 2, 3 steps away from the line of reflection. This bottom point is 1 step away from the line of reflection on this side, and 1 step away on the opposite side. So here are 2 other examples of reflection. Doesn't always have to go from left to right. We can go from right to left over the line of reflection, or we can even go from top to bottom, or in this case, it's gone from bottom flipping up to the top. So in all these cases, we would call this transformation a reflection, and in each of these, the shapes are still congruent. The third transformation we're going to talk about is a rotation. In rotation, the image is formed by turning the original image about a point, and so we will call this also a turn. So I have here a triangle, and this is the point, right, the vertex where the right angle is. That's the point that we're going to turn it or rotate it. So I'm going to see the direction I'm rotating in here, which is counterclockwise. I'm always keeping that point at the same place and just rotating it around that one point. And I've rotated it around basically halfway around the circle, or 180 degrees, and now I have placed it here as a rotation. We could also go clockwise with this shape, and it would rotate around to here. And remember that in rotation, reflection, and translation, each of those shapes, in each of those transformations, the shapes were all still congruent.